All right, so we are moving on into unit circle. One of the biggest things you'll learn in Trig, but actually pretty easy to memorize, easy to use once you get the hang of it. And you'll definitely use it all through Trig and Pre-Calc. So we're just going to give you the basics of it today. We are definitely doing these in class, and you will get to create one from scratch, and you'll see how easy it is. So why do they even call it a unit circle? Well, let's look at just your basic little circle here. We're on a coordinate plane, just like we always are. And let's just extend that line from here to here. The reason they call it a unit circle is because this radius is 1. So anything that's in unit measure is always compared to 1. And let's just call this angle in here. Let's make that our theta. Okay? We're just going to leave that alone for a minute. Let's just drop the vertical line down there. And now we've created a triangle. Right? Easy. So what if we were to do that? Let's go over here. Do the same thing. Okay? Unit circle doesn't really even matter how big the circle is. You're always going to assume that the radius is 1. So this is our radius. We still know this is our x-axis. This is our y-axis. So if we drop that triangle down again, our x is always going to represent the horizontal side. The y is always going to represent the vertical side. So let's just go through now and do some of our trig properties that we know. So sine, in this case, this is my x and my y. And this point up here would actually be, the coordinates for that point would be x and y, right? That triangle is x units across and y units tall, so that coordinate point would be x, y. So think about that for a second. Now let's come back over here. Well, we know that sine is opposite over the hypotenuse, and we know that this hypotenuse is 1. It's always going to be 1, okay? So the sine of theta would equal y over 1, or just y. Cosine of theta is going to be the adjacent over the hypotenuse. This is going to be x over 1. So now if I want to go back to my original triangle, instead of having x, y be my coordinates, well, my x is equivalent to cosine, and my y is equivalent to sine. So when you're dealing in the unit circle, instead of thinking of x and y coordinates, I want you to start thinking of cosine. Your horizontal is going to be your cosine coordinates, and your vertical are going to be your sine coordinates. Okay? And actually, you don't even need the theta on there. Let's just leave it sine. Keep it nice and super simple. Okay? So let's try and apply that a little bit. So here we've got just plain old reference triangle. No big deal. We don't have a triangle, right? We've just got a point. We can make that into a triangle. And so if I have that, well, I know that those coordinates are negative 3, 4, which means I went over 3 and up 4. So this triangle is 3 wide and 4 tall. And we can figure out the length of that side of the triangle based on these two, because of course we can use Pythagorean theorem. And 3, 4 is the first two parts of one of our Pythagorean triples. You probably know a 3, 4, 5 triangle. I'm going to give you a couple of other ones that might help. When you see them, you'll just know. So a 3, 4, 5 triangle, meaning 3 squared plus 4 squared equals 5 squared, which is true. 9 plus 16 equals 25. Another one is 5, 12, 13. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. That's true. And then 8, 15, and 17. There are a lot more of them. You could find many Pythagorean triples, but these are the most common that you'll see, and any multiples of this. So say I double all of these. You could have a 6, 8, 10 triangle. That would work. You could triple any of these. So you could have a 15, 36, 39 triangle. That would work too. If you multiplied all three of those values by the same amount, you would still have a triple. Okay, so I know that this radius now is 5 in this case. So if we wanted to find the sine of that theta, I know that sine is opposite over hypotenuse. So I would get 4 over 5. Okay. Can I do this when I don't even have anything drawn? Of course I can. So let's just plot the point -3, -6. And you can be rough estimate, that's fine. So -3 and then down -6. So we're going to draw that out there. let's make this my theta because that's coming there. Okay, so I know that I went over 3 and down 6. We're going to talk in a little bit about when you have positives and negatives and all of that, but measures of anything can't be negative. You have there, even though it's sitting in a negative space down here in the third quadrant, the length of that triangle is 3, the width is 3, the length is 6. So now we can find cosine. So cosine is adjacent over, oh, we need to find our hypotenuse first. Sorry about that. So we're going to have to go through and use Pythagorean theorem to do that. So we have 3 squared plus 6 squared equals our c squared. So we've got 9 plus 36 equals c squared. So we have 45 equals c squared, and then we take the square root of that. But then you got to ask yourself, is that the simplest I can get? Which it's not. And remember what I said before, you are never going to use decimals. You're going to leave things in radical form and you're going to leave things in fractional form because it's the most accurate. Okay? So let's get this cleaned up a little bit. Well, that can split out into square root of 9 and square root of 5. So then square root of 9 would be 3. So this is going to simplify down to 3 square roots of 5. So this radius is 3 square roots of 5. So if I want to find the cosine of that, now I've got an adjacent and a hypotenuse. So I have 3 over 3 square roots of 5. And I don't want to keep that radical down there. So let's remember how to rationalize the denominator. And all that means is that we're going to multiply the root out of it, basically. So square root of 5 over square root of 5. Well, square root of 5 times square root of 5 just gives us a 5. 5 times 3. And actually, we can cancel those out, can't we? Because we have a 3 on the top and the bottom. So on the bottom now, all we have is a 5. And on the top, all we have is radical 5. And that is the most accurate way to put those answers. So you're just going to leave them like that. Okay? Let's see. Given theta is in quadrant 4, so we're going to be dealing with something over here. And sine is negative 3, 5. Then find the cosine. So let's just sketch out picture pretty easily. Okay? Quadrants are a big thing in trig, and they're usually going to give you a range between this area and this area. That's what you're looking for. What happens within this area? So if we're looking at quadrant 4, we're looking down here. And I know that I've got sine of 3 over 5, which basically means that my triangle, I know 5 is my hypotenuse, right? Because I know that's going to be the hypotenuse. And my sine is going to be the 3. So this is my theta. Let's check that that makes sense. If that's my theta, I know I'm in this quadrant somewhere. Sine is opposite over hypotenuse, so I've got that right. And then think about which one of those would be the negative. Oops, sorry, let me get my screen fixed. Okay, the hypotenuse is never negative. Never negative. Okay. Your ratio might be negative, but that's going to be because of where either your horizontal or vertical coordinate sits. So the hypotenuse itself won't be a negative, even though this ratio can be negative. So in this case, that negative 3, and that should make sense to you, it's a y value that's below the x-axis is what's making that negative. So again, that's a 3, 4, 5 triangle. This would be 4 wide. So cosine of theta is adjacent over hypotenuse, so that's going to be 4 over 5. Easy enough? Good. Let's move on. One thing, if you haven't noticed it yet, I'd be surprised, but you notice that trig is very fraction and ratio heavy. It is all ratio dependent, actually. So if you weren't real comfortable with fractions before, you're going to get comfortable with them, but they are very simple fractions to manipulate. So let's go back in and put our sine, cosine, and tangent that we know pretty well. So we know that that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. When you're finding the reciprocal trig functions, it is exactly that. It's the reciprocal of each of these. The only one that might, in remembering them, I always remember that the s and the c's go together. So the reciprocal trig function of a sine is a cosecant. So this is cosecant. The inverse of a cosine is secant, which I know seems a little illogical, but that's okay. And the inverse of tangent would be cotangent. And to find those, all you're going to do is reverse those relationships. So cosecant would be hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. It's pretty simple. They're just a different method that you can use. So down below, we're now going to try and find all of our 6 trig functions. So if I ask you on a quiz, find all 6 trig function values, you would do what we're going to do right here in this section. Okay, so using theta, sine is our opposite over our hypotenuse, so that would be 5 over 13. Cosine is adjacent over hypotenuse, so that's 12 over 13. Tangent is opposite over adjacent, so that would be 5 over 12. All I'm going to do for these is just take the reciprocal of those relationships. That would be 13 over 5 for the cosecant, 13 over 12 for the secant, and 12 over 5 for cotangent. You want to go back and check that? We certainly can. So that would be the hypotenuse over opposite for cosecant, which is 13 over 5. That's what we've got. It would be a hypotenuse over adjacent, 13 over 12. And we would have adjacent over opposite, which is 12 over 5, just like that. Okay, so here's an example of having a range of what they're asking for. So given that our theta is in between pi over 2 and pi, so I want you to think about what quadrant that is. And sine is 8 over 17. Find all 6 trig functions. So if you remember, you can always sketch it out. Remember that here we're at 0 pi. Here we're at pi over 2. Here we're at pi, 3 pi over 2, and a full time around the horn is 2 pi. So we are going to be working in quadrant 2 in this case because it's all of our angle measures between pi over 2 and pi. So we're in quadrant 2. And I know that this means that this is my opposite over hypotenuse. So I know that my radius coming out is going to be the 17. And then that height, since that's my sine, is going to be 8. And my theta will be down here. So this measurement, our cosine measurement is actually going, sorry, not our cosine, well, our horizontal measurement is going to be negative because we're now left of center, right? So let's see, so if we have sine of theta equals 8 over 17, then we already know that cosecant is going to be what? It's going to be 17 over 8. So that's easy enough. We need to calculate this amount right here. So let's do that real quick. So use Pythagorean theorem, and you could flip it around actually and do 17 squared minus 8 squared equals a squared. So I've got just do that real quickly on the calculator. So got 17 squared minus 8 squared equals 225, and the square root of 225 is 15. Oh, that was one of our triples, wasn't it? So 225 equals a squared, so that value is 15. So now here's where you really need to be aware of what quadrant you're in. This is going to be a negative 15 because it's on the left of, and this scale clearly is not drawn, this triangle is not drawn to scale. Totally fine. It's almost better for you to learn it when it's not drawn to scale so you don't tend to rely on that. So our cosine is going to be adjacent over hypotenuse, which would be negative 15 over 17. And then the secant for that would just be the reverse, so negative 17 over 15. And tangent will be opposite over adjacent, and that will be negative 8 over 15. The whole ratio is negative because of that. And then cotangent will be negative 15 over 8. Oh, there we go. Sorry about that. So let's talk about those positive and negative quadrants, okay? And just think about, you can always, I want you to start thinking about cosine and sine for x and y. But think about, you can always go back to x and y as your reference points if that is still confusing to you. So if I have a point in here, I know that they are positive, right, in the first quadrant. In quadrant 2, my x value or my cosine value is negative, but my sine value is still positive. We're still above the x-axis. Down in quadrant 3, everything's negative. I've got negative cosine, negative sine, right? And then in quadrant 4, I have exactly the opposite of what I've got over here. I have a positive cosine, but a negative sine, okay? So let's see if we can figure these questions out. What quadrants can theta lie in if sine is greater than 0, which means I'm up above, I'm on the top half, and cosine is less than 0? So think about where that's at. I'm positive in my sine, but I'm negative in my cosine. So I'm going to be there at quadrant 2. If sine theta and tangent theta have the same sign. So let's think about where that happens. So here, I know it's always going to be positive no matter what. So let's see. So sine theta in the first quadrant would be positive because I would have a positive divided by my hypotenuse, which is always positive. And then tangent would be a positive, it would be my opposite over my adjacent, which are both positive. So quadrant 1 works. Quadrant 2, let's see, because my sine would be positive, so I would have that, but my tangent's going to be negative because I would have opposite over adjacent, and my adjacent is negative, so 2 is not going to work. I'm thinking that quadrant 3 is going to work also because I've got the same signs going on again. So let's see. I'm saying this kind of abstractly, but you can always stick a line in there and figure out what that would be, okay? And just use symbols. This one's negative, this one's negative. So, and this is always positive. So if I look at the sign of anything in here, of that theta, it would be opposite over adjacent, which is negative. And then, opposite over hypotenuse. And then, my opposite is negative, and my hypotenuse is positive, so that gives me a negative. And then my tangent would be opposite over adjacent, which is negative over negative, which gives me a positive. So it's not in quadrant 3 either, so that's not going to work. And then let's check quadrant 4. So that would be a little baby triangle. So this is positive, this is negative, this is positive, okay? So my sine would be opposite over hypotenuse, which is negative, and then my my tangent would be opposite over adjacent, which is also negative. So 4 works. I think we need to go back and check 2. What do you think? Let's go in there and check 2. So this is negative, this is positive, this is positive. So in 3, my sine would be opposite over hypotenuse, which is positive, and my tangent would be opposite over adjacent, which is negative. No, I was right. So 1 and 4 are the only ones where my sine and my tangent match up. So cotangent and secant have opposite signs. So let's go in and put some little baby triangles in all of them. That might help. You can do this in a separate circle if you want to. That's fine. So let's see. I'm kind of making them different sizes on purpose just so when they drop down they're not right on top of each other. Okay, so here I've got a positive, positive. All my hypotenuses are positive, obviously, right? And this is positive, that's negative. My signs are positive, that's negative, negative. Okay, so I've got everything labeled. Now let's just see. So in quadrant 1, cotangent would be adjacent over hypotenuse. Or sorry, adjacent over opposite. So in quadrant 1, let's do this. Let's make a little chart. Okay. So in quadrant 1, 2, 3, and 4. This probably help. This would be a good thing for us to revisit in class too. So here's my cotangent, here's my secant. And remember that cotangent is adjacent over opposite. Sorry. Adjacent over opposite, and secant is the inverse of cosine, so that's going to be hypotenuse over adjacent. So let's just do these one at a time. So here, my adjacent over opposite. So adjacent over opposite is going to give me positive. Positive divided by positive. Here, I have adjacent over opposite, so that's going to be a negative over positive. That's negative. Down in quadrant 3, I have adjacent over opposite, which is going to give me a positive, because negative divided by negative is positive. And here I will have adjacent over opposite, which will give me a negative. Okay? Now let's see which secants match up with that, or have opposite signs. So secant is going to be hypotenuse over adjacent. So in quadrant 1, that's going to be positive. Hypotenuse over adjacent, that's going to be negative. Adjacent over hypotenuse, there's going to be negative. There's one winner. It has opposite signs. And in quadrant 4, I have adjacent over hypotenuse, which is positive. So anything below the cosine axis or the x-axis is going to have opposite signs. So in quadrant 3 and quadrant 4. Okay? We'll do a lot of practice on unit circle and all these reference angles and start really becoming clear for you. Okay, great. Thanks.